Very good evening all. Today I'm going to present my research topic on the question of graduation type for all. So this is my curriculum vitae, what I have been achieved till now. Now I'm PhD pursuing in NIT Trichy. This is my outcome during PhD. So as of now I have published 13 journal and 6 submitted in conference 3 and some 3 2 papers submitted. This is my research brief. Today I'm going to present out of my all work selected 3 topic I'm going to present very briefly. So first one starting with still at quarter mode SW self-deprecation antenna. Second one I will start with half mode SW for self-deprecation antenna, and third one for power divider. So this is a history of my research topic, that is SW technology, how it started and how it's end now as of till now, how it's going on. So this is the history of my research topic. So basically, I'm going to discuss very briefly about the introduction of SIW. That is how SIW come to the how SIW come to the market. So regarding this, I wanted to discuss. Initially, microstrip technology is the high profile and microstrip technology used for everywhere due to their low loss and low loss and very compact size. But main point is that microstrip technology is unable to handle the power handling capacity. So on the other hand, the rectangular waveguide has that facility, but due to the fabrication challenge, so it's difficult to convert to planar form. So to mitigate that issue, SRO technology came. So you can say in simple word, SRO technology is the intermediate structure between microstrip as well as rectangular waveguide. So this is a classification of shadow technology. So nowadays the trends going on for the compact. So for the compact size initially, so full mode SIW. So if you convert to half mode SIW, that is size reduction 50%. If you again go for quarter mode SIW, this is 75% reduction. You can achieve it through half mode quarter mode. So again in the half mode quarter mode, there is one more drawback is there. So in the you can see the figure. In the figure, the magnetic wall is there. The cutting part is there is a extra unwanted radiation loss will be there. So to mitigate the extra unwanted radiation loss, so new technology we have been used here, that is shielding concept. So in the shielding concept, what you have to do? You have to put the 2 extra rows of wires near to the cutting part and one slot. So in that way you can reduce the leakage like losses and unwanted radiation loss. Both you can do. So one more good point is here, like if you see the quality factor point of view. In the quality factor point of view, if you compare with full mode SW and quarter mode SW and shielded quarter mode SW, you can see here full mode SW 391, quarter mode SW 202, and shielded quarter mode 301. So here you can see that 33% extra you can achieve from quarter mode to shielded quarter mode SW. This is my first work, a shielded quarter mode SW based self-deprecating antenna for full space band high isolation. So here step 1 full mode I have taken, and that quarter mode I have in 4 part I have in divided in 4 part. Then I have used here Y-shape slot. In this Y-shape slot, I have achieved here dual band, that is self-deprecation antenna. So self-deprecation is nothing but like at a time you can one you can on and other one you can off. So at a time it can work for one frequency. So this is the fabrication prototype I have been used for RTW 5870 and thickness 0.787 mm. And so I have been prototype the fabricated predicted equivalent circuit model for the fabricated device. So you can see here the circuit parameters I have been plotted in the table. So the comparison table I will mention here, like circuit model, equivalent circuit model. So you can see here the equivalent circuit validation happens here. So it's not like only for some particular frequency you are designing. So here the main thing is the big by varying the slot dimension, you can achieve the different kind of frequency. Like if you vary from V1 from 15.7 to 17.7, you can see the S22 is keeping constant and S11 is varying from lower end. Similar way, if you change from A1 to 12.2 to A1 14.2, S11 is constant, S22 is vary from starting right hand side. So you can see, so in this way you can accommodate different frequencies. So then figure C is the my simulated simulation measured and equivalent circuit model. You can see here the first frequency 3.47, second frequency 3.84. So in this we are achieving 47 dB isolation, that's S211. So as of now in the literature, the 47 dB isolation is the highest isolation for the diplexing antenna. In the gain also I am getting around 5 dB for over entire band. So this is second work. So similar way, so I will select diplexing antenna. So 3 frequency it will work for 3 frequency. So you can see here at a time 1 frequency will work, other 2 frequency will constant here. So similar same pattern we have followed here. This is a fabricated prototype. Here you can see here first frequency is 2, and second frequency is 4.96, and fourth frequency is 5.86. So in 3 frequency I can accommodate here. This is the predicted equivalent model. So you can similarly you can accommodate different type of frequency by varying the single parameter. So this is the compact software integrated with triple and quad band power divider. This is a quad band power divider. So as of now in literature we have not having a several quad band power divider. This is the first time we have been proposed for quad band power divider. Here CSRR and USS used for getting the triple band quad band power divider. So initially dual band power divider we achieved by employing the CSRR on the top of the metal. After that we have been in the bottom side we have been used USS, two USS, so to achieve triple band quad band power divider. This is a fabricated prototype. So 5870 rattle we have been used here. So these are experimental validation. So you can see here the first frequency is 3.47, second frequency is 4.86, and third frequency is 6.23. And similarly, and here also fourth band we have been achieved 3.47, 4.36, and 6.23 and 7.23. So four frequency have been achieved here. So in the entire band, isolation is around more than 14 dB in the entire band. So it's quite good for quad band power divider. So this is my fabricated prototype for the published work in during my PhD research work. So around 13 work I have been prototype I have been fabricated starting from 6 devices. So this is my publication. So first two was is under review, and the second the applications were published in AWPL, IEEE. Second one published in IEEE MWCL, and Zalanda Pellet web application. So my IEEE transaction is author. This is my publication. So is my conference I have been published here. It's a future research plan. How I have to improve my research. Like what I have been found that we need to improve. So to enable band pass filter, employing SIW, shielded HM SIW, and shielded quantum module for 5G application I need to focus. And this is the research plan to highly compact multiplexer. These are two novel power divided by SIW and shielded HM for multi-band 5G application. So this is a research plan for highly miniaturized self-complete antenna for employing SRW, HMSW, KMSW for 5G RF and front end. So everything I mentioned is my research collaboration. So Kuchan Chang and Dr. S. Kujal, IEEE fellow, and Dr. Chinmasa, and there is my references. So in this, I'm just concluding in here. So if anything, if my paper will get select, so I may go for like some expand way I can able to explain it. Thank you.